Good morning. Today we discuss the topic solution of wave equation in 3 dimension in Cartesian coordinate. As we know, the partial differential equation is of the form curl 2u by curl t square is equal to c square del square u. Del square can also be written as curl square u by curl x square plus curl square u by curl y square plus curl square u by curl z square. So the equation reduces to curl square u by curl x square plus curl 2u by curl y square plus curl 2u by curl z square is equal to 1 by c square curl 2u by curl t square. Let this equation be 1, and with the conditions as curl u by curl x is equal to 0 at x is equal to 0 and x equal to a. Similarly, curl u by curl y is equal to 0 at y equal to 0 and y equal to a, and curl u by curl z is equal to 0 at z equal to 0 and z equal to a. With one more condition, u of x, y, z, t is non-zero at t is equal to 0. To solve this problem, we use the separation of variable method. So for that, we take u of x, y, z, t is equal to x of x, y of y, z of z, t of t. Let this equation be 2. Differentiate with respect to x, we get curl 2u by curl x is equal to dx by dx y z t. Similarly, we will find curl 2u by curl x square is equal to d2 capital X by dx square into y z t. Here y, z and t are treated as constants. In the same manner, we will find curl 2u by curl y square, which is equal to x d2y by dy square z t, and curl 2u by curl t square is equal to x y d2z by dz square into t. And curl 2u by curl t square is equal to x y z d2t by dt square. Put all the above equations in one. We get d2x by dx square yzt plus d2y by dy square xzt plus d2z by dz square xyt is equal to 1 by c square d2t by dt square xyz. Now we will divide throughout by x, y, z, t, and we will get 1 by x d2x by dx square plus 1 by y d2y by dy square plus 1 by z d2z by dz square, which is equal to 1 by c square t d2t by dt square. Let this equation be 3. Now as we see that on the right hand side is the term of independent of t only, so we take it equal to some constant as minus p square. So what we will get, d2t by dt square is equal to minus c square t p square, which is equal to d2t by dt square plus c square t p square is equal to 0. Similarly, we get all the above equations as we take the constant as for x minus p1 square, for y minus p2 square, and for z minus p3 square, and we get the required equations as d2x by dt square is equal to minus x p1 square, d2y by dt square is equal dy square is equal to minus y p2 square, and d2z by dz square is equal to minus z p3 square. And we know p square is equal to p1 square plus p2 square plus p3 square. Now we will solve all the above equations. So solving all the above equations, we get the required result as x of x is equal to a1 cos p1 xt plus b1 sin p1 x. Y of y is equal to a2 cos p2y plus b2 sin p2z. Let these equations be 4 and 5. And z of z is equal to a3 cos p3z plus b3 sin p3z is as equation 6, and t of t is equal to a4 cos pt plus b4 sin pct as equation 7. and using all the conditions which are given, we get curl u by curl x of 0 y z t. We take here x is equal to 0, so curl u by curl x is equal to 0. So the required solution we get from this is x dash 0 is equal to 0. Similarly, we will get x dash a is equal to a, and using the condition 4, we will get x dash 0 is equal to 0. So from that, what we will get, minus a1 p1 sin p1 into 0 plus b1 p1 cos p1 into 0. So by comparison, we will get p1 is equal to 0. X dash a is equal to 0, so minus a1 p1 sin p1a is equal to 0. So we will find the non-trivial solution for this equation. So what we will take, sin p1a is equal to 0. So p1a is equal to n pi p1 is equal to n pi by a for n is equal going from 1 to infinity. Similarly, we will get the required equations. Solving the equation 5, 6, we get the solution as b2 is equal to 0, b3 is equal to 0, and p2 is equal to n2 pi by a, and p3 is equal to n3 pi by a. And as we know that p square is equal to p1 square plus p2 square plus p3 square. So putting all the equations, we get pi square by a square into n1 square plus n2 square plus n3 square. And one more another condition which is given as u of x, y, z, t is non-zero for t is equal to 0. So from that, we will get t of t is equal to c cos pi ct by a under root of n1 square plus n2 square plus n3 square. Combining all the equations and putting it into 1, we get the solution as u is of n1, n2, n3 function of x, y, z and t, which is equal to alpha of n1, n2, n3 cos n1 pi by a cos n2 pi by a cos n3 pi by a into cos pi ct by a under root of n1 square plus n2 square plus n3 square. Now using the superposition general principle, what we will get the solution, u of x, y, z, t is equal to summation n1 square plus n2 square plus summation from n1 going from 1 to infinity, similarly n2 going from 1 to infinity and n3 going from 1 to infinity, alpha of n1, n2, n3 cos n1 pi by a cos n2 pi by a cos n3 pi by a cos pi ct by a under root of n1 square plus n2 square plus n3 square. So it completes the proof. Thank you.